Bismillahirrahmanirrahim. So this is the second part of the 8th lecture of statistics and probability theory. We will continue with the topic measure of dispersion. Moments. A moment designates the power to which deviations are raised before averaging them. For example, the quantity 1 over n summation x minus mu is called the first population moment. As you can see from here, we have capital N in the divisor and the Greek letter mu here. So it means that this is the parameters and this is the population moment and is denoted by mu1. Similarly, the quantity 1 over n summation x minus mu whole square is called the second population moment and is denoted by mu2. The corresponding sample moments are denoted by m1 and m2. Mu1 and mu2 are population moment and m1 and m2 are sample moments. In general, the rth moment about the mean is the arithmetic mean of the rth power of the deviations of the observations from the mean. It means that first population moment about mean, as we are taking deviation from the mean, so these are the mean moment, or you can say that they are central moment, summation x minus mu over capital N. Second population moment about mean mu2 is equal to summation x minus mu whole square over capital N. So the first sample moment about mean is equal to m1, as this is the statistics, so we are representing this with small m1, whereas when we were talking about first population moment, we represented it with mu1. So m1 will be equal to summation x minus, as we have here mu, so the sample statistic is x bar, and we have here capital N, so the corresponding is the small n. So this is the first population, first sample moment about mean m1. Second sample moment about mean m2 is equal to summation x minus x bar whole square over n. As you can see from here, this is the same formula which we have discussed for the variance of the ungrouped data mean mu r is equal to summation x minus mu raised to power r over capital N. So the corresponding rth sample moment about mean mr will be equal to summation x minus x bar whole raised to power r over n. So this is the rth population moment about mean, and this is the rth sample moment about mean. When you substitute r is equal to 1, r is equal to 1, you will get first population moment from here, which is mu1. So this is the first population moment by substituting r is equal to 1. When you substitute r is equal to 2, you will get mu2 is equal to summation x minus mu whole square over n. Similarly, you can get the third and fourth population moment about the mean as well by substituting r is equal to 1. You will get the first sample mean moment, which is m1, is equal to summation x over n. And here we will have the small n, as we are talking about the sample moment about mean. Similarly, you can get second sample moment about mean by substituting r is equal to 2, which is obviously the variance, and by substituting r is equal to 3 we will get the third moment, and by substituting r is equal to 4 by substituting the fourth moment. So these are the population moment about mean and the sample moment about the mean. Here we have discussed the formula for the ungrouped data. When the data is, then obviously the formula for the rth population moment about mean and rth sample moment about mean will be changed. So the rth population moment about mean will be summation fx minus mu whole raised to power r over summation f, and rth sample moment about mean will be equal to mr summation f x minus x bar whole raised to power r whole divided by summation f. So these are the rth population moment about mean and rth sample moment about mean for the group data. By substituting r is equal to 1, you will get the first population moment about mean and first sample moment about mean. Similarly, by substituting r2, r3 and r4, you will get the second, third and fourth moment about mean, in both cases in population moment and sample moment as well. Example. So as you can see, this is the same data we have discussed in previous lecture. These are the marks of the 9 students and we are representing it with x, and we need to find the 4 moments about mean, and as this is the ungrouped data, so we will use the formula for the ungrouped moment of the mean, and for this purpose you need to find the x bar, which is summation x over n, and we know that summation x is equal to 360, and we will get by summing over this column x. So 360 divided by 9 will be equal to 40 marks. So as you know that mr is equal to summation I is equal to 1 to n x I minus x bar raised to power 1 over n. It would be raised to power r, as we are saying that rth moment. To find out the first sample mean moment, substitute r is equal to 1. So we will get m1 is equal to summation x minus x bar raised to power 1 over small n, and by substituting r is equal to 2, we will get m2. Here we have m2. m2 is equal to summation x minus x bar whole square over n, which will definitely equal to the sigma square. Second moment is basically the variance of the data. By substituting r is equal to 3, here we are substituting the r is equal to 3 in the general formula of rth moment. You will get the third moment, and by substituting r is equal to 4, we will get the fourth moment. So for the purpose to calculate the first moment, summation x minus x bar whole raised to power 1 over n, we know that there are 9 observations. We know that the mean is 40, but we should have the column x minus x bar, to which we will sum over and find out this particular value. So what we will do, we will find out this column, which is x minus x bar, which is 32 minus 40, which is minus 8, 36 minus 40, which is minus 4. By summing over this column, we will get 0. So what we will do, we will substitute here 0, 0 divided by 9 will obviously equal to 0. If you remember the first property of the mean, what it says that the sum of deviation from its mean is always equal to 0. So what is this in the numerator? This is the sum of deviation from the mean. So it is obvious that first population moment, or the first sample moment about the mean, will always equal to 0. We can say it without calculating this particular column, because we know that this is the property of the mean, and first moment about mean will always equal to 0, as sum of deviation from its mean is always equal to 0. Now for the sake of the second moment, we need to find the summation x minus x bar whole square. So what we will do, we will find out the column x minus x bar whole square. So what is that? X, 30 minus 40. This is basically 30 minus 40 whole square. And this should be whole square. This is 32. 32 minus 40, as x is 32 here. 32 minus 40 whole square, which will be minus 8 whole square, which will be definitely equal to 64. Similarly, all other values can be found out. 36 minus 40 whole square, which is minus 4, and whole square of minus 4 will be 16. By summing over this column, we will get 232. By substituting this in this formula, we will get 232 divided by 9, which is 25.78 marks square, which is equal to variance of the data. So the first moment about the mean is always equal to 0, as we know the property of the mean, that the sum of deviation from its mean will always equal to 0, and the second moment about mean will always equal to variance. Similarly, the third moment about mean can be found out by this formula. For this purpose, we need to know that summation x minus x bar whole cube, and here we have find out x minus x bar cube. It means 32 minus 40 cube, which is minus 512. And by summing over this column, we will get 186, and by this substituting this value here, 186 divided by 9, we will get 20.67 marks cube. Similarly, fourth moment can be find out. This column will give us the summation x minus x bar whole power 4, which is 10708. By substituting this value here, we will get 1189.78. It means 1189.78 marks raised to power 4. So these are the first 4 moments of the mean, about the mean, and these are the first 4 sample mean moment. These are also called the central moments. We also name them as central moments, as we are taking the deviation from the mean. So what is symmetric and skewness? Basically, we have find out the 4 moments about the mean. So what we are going to do, we will use those moments to find out the some particular features of the data, like about the symmetry of the data and about the peakness of the data. So a distribution in which the values equidistant from the mean have equal frequencies is called symmetric distribution. Any departure from symmetry is called skewness. In symmetric distribution, we have mean is equal to mod is equal to median. It means all 3 measures will be same. And if we draw the graph for the symmetric distribution, it would be bell shape and it would be somehow like this. That is, we will have mean, median and mod exactly at the center of the data, and 50% of the data will be at the left side of the mean, median and mod, and 50% of the data will be at the right side. So this is the shape of the symmetric distribution. Any departure from this symmetry will lead to skewness. So when the distribution is not symmetric, it is basically skewness. So there are 2 types of skewness, positive skewness and negative skewness. If right tail is longer than the left tail, then the distribution is said to be positively skewed, or you can say that there is positive skewness. If you draw it, it would be like this. So this would be probably the shape for the positively skewed data, in which the tail of the right side is longer than the left side, and in this case mean is greater than median and greater than mod. So what we will definitely have median at the center, at the peak we will have the mod of the data, and here we will have then median, and then we will have the mean. So this one is the mod, and this one is the median, and this one is the mean. So this is the distribution for the positively skewed data, in which we have the longer tail at the right and left tail is the smaller, and the mod will come at the peak, which is the smallest one. Then we will have median, and then we will have the mean. In the case of negatively skewed, what we will have? In the case of negatively skewed, the left tail is longer than the right tail. So the shape of the distribution would be somehow like this. This would be the mod. We will have the longer tail here, and we will have the median at this side. And then we will have the mean, here. So in the case of symmetric distribution, mean will be equal to median will be equal to mod. In the case of positively skewed, mod will be the smallest one, then we will have the median, and then we will have the mean. And in the case of negatively skewed data, the mod will be the largest one, then we will have the median, and the smallest one will be the mean. As this is the, if you consider the real number line, we will have this scale is from minus infinity to infinity, so we will have the increasing one trend, and here we will have this side will be the decreasing one. So this is the relationship between symmetric distribution and skewness. Any departure from symmetry will lead us to the skewness. So how to find out the skewness, measure of skewness? For the purpose to calculate that the data is skewed or not, because as you are studying the descriptive statistics and you are highlighting the main features of data, you have already find out the central value of the data, you already know the dispersion of the data. Now you need to find out what is the shape of the data. Either it is symmetric or it is skewed, and if it is skewed, it is positively skewed or it is negatively skewed. For this purpose we use this SK, this is coefficient of skewness, and we usually name it as beta 1, and this is equal to M3 over S raised to power 3. This S is basically for the standard deviation. So the beta 1 will be equal to M3, which is the third moment. Now we are using the moments to find out the measure of skewness. M3 over S raised to power 3. Now if your beta 1 is equal to 0, it means that the data is symmetric. And if your data is less than 0, if your coefficient of skewness, measure of skewness, is less than 0, it would be negatively skewed. And if it is greater than 0, then the data is positively skewed. So this measure basically help us to find out that either the data is symmetric, or it is negatively skewed, or it is positively skewed. Let me go back to the example which we have discussed. In this example, I am going to find out the beta 1, which is equal to M3 over S raised to power 3. So as this is the sample moment, so this would be S square, and the S would be under root 25.78. So beta 1 will be equal to M3. What is the value of M3? 20.67. We will substitute it here. 20.67, and we need to find out the standard deviation, which is under the root 25.78 and whole raised to power 3. So beta 1 is equal to 20.67 under the root 25.78 power 3. So this would be equal to 0.158, and this is obviously greater than 0. It means your data is positively skewed. It means when you draw the data, shape of the data, it would be somehow like this. It will have the larger tail at the right side. So your data is positively skewed. So this is the way to find out the description of the data, that either your data is symmetric or positively skewed or negatively skewed. So now we will going to find out the kurtosis. So what basically the kurtosis is? This is basically the measure of the degree of the peakness of the data. If you concentrate on the diagram, what it is showing, you are seeing the three shapes of the data. This is the blue one and the maroon one, and one is the green one. All of them have almost same mean, as this is the center of the data, but you can say that the dispersion is different in all the cases. And this blue one is the more flat one, so we will call it platykurtic. And this one is the moderate one, so we will call it mesokurtic. And this green one is the one which is a thin one, and it has the highest peak, so this one is the leptokurtic. So basically, whenever you find out the degree of peakness of the data, that either your data is of leptokurtic type or mesokurtic or platykurtic, you need to know that you need to find out the kurtosis of the data. For this purpose, we have the measure of kurtosis, and this is usually represented by beta 2 is equal to mu4 over mu2 square for population data and m4 over m2 square for sample data. So this is the kurtosis, and we will find out this kurtosis B2 for the data which we have discussed here. And this one is, we have, okay, so kurtosis will be equal to, you can say beta 1, beta 2, as beta 1 is for the skewness. For the population, this is population statistic. And if we are dealing with the sample, which we usually deal with the sample, we name them beta 1. Similarly, B1, similarly in this case, you can see it B1 as you are dealing with the sample. So this will be equal to, I will write it B1 instead of beta 1, because we are dealing with the sample, and B2 instead of beta 1 because we are dealing with the sample, just for the sake of the discrimination between sample and population. So this would be B2 M4, which is the fourth moment. Now I am utilizing the fourth moment and second moment for the sake of finding out the measure of kurtosis, which is equal to 1, 1. So this is equal to 1.79, and if your B2 is equal to 3, it means that your data is mesokurtic. If I go back to the diagram, which is this, and if this, I will discuss it here. If this is equal to 3, it means that the degree of peakness is of like mesokurtic. If it is lesser than 3, it means that it is platykurtic, and if it is greater than 3, it means that it is leptokurtic. This is the situation for this. For the purpose of this, B1 should be less than 3, and for the purpose of the data for to be the mesokurtic, B2 should be equal to 3, and it should be B2, and for this purpose B2 should be greater than 3. So this is the criteria to judge that whether the distribution is platykurtic, leptokurtic or mesokurtic. What you have find out that this is less than 3, so it means that distribution is of like platykurtic, because this is lesser than 3, so it would be like this one. Like this one. So this is the way to find out the measure of kurtosis. What we have learned here in this lecture, that how to calculate the mean moments. We got to know that there is a formula for the rth moment, mean moment, and you can find out the mean moments for group data and ungroup data as well, and we utilize those moments to find out the skewness and kurtosis. And for this purpose, you need to find out the measure of skewness and measure of kurtosis, which will highlight the two main very important features of the data, which is the shape of the data and degree of the peakness of the data.